And I've shared the screen, so anytime you want to start, feel free to.
Good, good enough. Okay, Marty, go ahead. Take it away.
Okay, sounds good. Let me get the screen share going here.
You were a little weak on the audio right at the start of that.
Okay, how about now?
Still a little weak.
Okay, let me adjust the audio here. Just one sec.
That came up a bit.
Okay, how about now?
Still about the same, but it's certainly readable.
Okay, good. Okay, get the screen sharing going here anyway. Okay, hi. I'm Marty Lynham. I'm WA7MJL. I live in Bellingham, Washington, and you see my email there. Anyway, today we're doing unit T7, which has 4 elements. There should be one question on the test from each of the elements. Unit T7A is station equipment and basic circuits, push to talk and modulation. Anyway, I'll just jump into it. If you got any questions out there, just give me a yell and we'll stop and we'll talk about it. Anyway, question A01. Which term describes the ability of a receiver to detect the presence of a signal? Well, you look at the question pool there. Linearity, sensitivity, selectivity, and total harmonic distortion. Really, there's only 2 that make any real sense. And why aren't we advancing? The answer is sensitivity, which kind of makes sense. If your receiver is sensitive to a signal, it will pick up a signal. A2, what is a transceiver? Well, you think about that. You think about the devices that you have, a transmitter and a receiver, you put those together, you get a transceiver. So that's a box that is combining a transceiver and a receiver. Question A3, which of the following is used to convert a signal from one frequency to another? The answer to that is a mixer. And what that does is it mixes one signal with another signal to convert. For example, if you have 100 megahertz signal mixed with a 98 megahertz signal, you end up with a 2 gigahertz signal. So it mixes the 2 frequencies. Down here, you've got kind of a demonstration that you've got a frequency in, a frequency in, and a frequency out. A4, which term describes the ability of a receiver to discriminate between signals? Well, to discriminate, means to select. So the term that they use is never see selectivity, because you're selecting a signal out of a group. For example, in the little diagram here, you have an unwanted signal here and a wanted signal here, and you're selecting that frequency or that signal. What is the name of a circuit that generates a signal at a specific frequency? Well, from the other units, you know that an oscillator generates a signal of a specific frequency. Here's one that's a little unusual. Most hams don't really use these devices, but what is a device that converts the RF input and output of a transceiver to another band? And here's an example of the box. It's generally used for very high frequency signals, to drop them down into a frequency that your receiver can actually receive, and that is called a transverter. Number 7 here in section A, what is the function of a transceiver's PTT input? Well, it helps to know what PTT stands for, and that stands for push to talk. And so that is a switch that switches a transceiver from the receive function to the transmit function. So you push the button on the microphone, for example, to talk. And when you release the button, it goes back to the receive function. Question 8. Which of the following describes combining speech with an RF carrier signal? The term for that function where you combine speech with an RF carrier to actually transmit that speech is called modulation. Question 9 here. What is the function of the SSB CW and FM switch on a VHF power amplifier? Well, that is a switch that sets the components of the amplifier in proper operation in a selected mode. Generally, VHF is run in the FM mode. Some VHF transceivers do support both single sideband SSB and CW, which is code. Anyway, to make sure that the power amp is in the proper mode for that, or in the proper configuration for that mode, they have a switch that lets you select which of those modes you wish to use. Question 810, what device increases the transmitted power from a transceiver? Well, that's a special box that is called an RF power amplifier, which actually boosts the output. Oftentimes, the output from a transceiver might be 50 watts. A power amplifier can actually boost that to be several hundred watts of power output. And the converse actually of a power amp is on the receive side. Where is an RF preamplifier installed? A preamplifier is a box that boosts the received signal so it's more readable on the receiver, and it is placed between the antenna and the receiver. Generally, they're not used commonly unless you're a really advanced ham, but they will, if they're used, will improve your received signal level. And in this unit, there are only 11 questions. So this is the end of block A. Block B discusses or asks questions about the symptoms, causes, and cures of common transmitter and receiver problems. So B01, for example, what can you do if you are told that your FM handheld mobile receiver is over deviating? One of the most common problems that new hams have when they're talking on a microphone is they hold the microphone right up to their mouth. And when you speak in a fairly loud voice, that will cause the signal to be overmodulated, or it's called overdeviating. And the way you fix that is you just move the microphone away from your mouth. Often, one of the problems also is that hams talk directly into the microphone. You want to talk kind of across the microphone. That way you don't get over modulation and you don't get the pops and whistles will happen when you talk directly into the microphone. B2, what would cause a broadcast AM or what would cause a broadcast AM or FM radio to receive an amateur transmission unintentionally? The main reason is that the receiver in the radio is unable to reject these strong signals outside the AM or the FM band. And a standard FM radio is in the 100 megahertz band, and a VHF transceiver is in the 144 megahertz band. And you would think that the 100 megahertz AM or FM receiver, wouldn't actually receive it. But if the signal is very, very strong from the transceiver at the FM radio, it can overload a circuitry in the radio and actually receive the transmissions that are being transmitted 44 megahertz above the actual frequency that the radio is set for. And that's just because the circuitry in the radio is not that selective, to use that term again, and it actually receives the signals from the transceiver. B03, which of the following can cause radio frequency interference? Where you have overloads, harmonics, spurious emissions, and the answer is all of these are actually correct. Any of these can actually cause radio frequency interference. And which of the following could be used to cure distorted audio caused by RF current on the shield of a microphone cable? Sometimes when you have a long cable, you can actually get noise generated by your transmitter on the microphone cable. And to fix that, you would use a ferrite choke, which is just a little inductor that will reduce the amount of interference. In the pictures here, you've got a couple of examples. Here's one that just clips around the cable. These are actually USB cables for your computer, but they often have the same problem, and ferrite chokes are used to actually reduce that kind of interference. Question 5, how can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? And again, that's the same kind of answer. You can get little chokes or filters that will filter out the offending frequencies. Here is an example of one where your coax cable from the wall, for example, screws in here. You have your filter and a short cable to screws in here. Question B6, which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? That's one of the major complaints that some folks have about amateur radio operators, and it's very seldom the amateur's fault. It's oftentimes a fault in the cables or the selectivity of the person's TV, but you still want to try and keep them happy. But the answer is you need to make sure and be able to demonstrate that your station is functioning properly and is not causing interference to your neighbor's TV or radio. One of the easiest ways to do that is to get on the phone with them and tell them, okay, I'm transmitting now. Do you have an interference? I'm not transmitting now. Do you have interference? If interference does happen when you're transmitting, well, that means there may be a problem in your station, and you should strive to make sure that all of your cable connections are tight, that you don't have any bad cables, and that all of your transmitting equipment's on the right frequency, and you don't have any problems. B7, which of the following can reduce overload of a VHF transmitter by a nearby commercial FM station? It is possible that if you're really close to a high power transmitter, let's say transmitting 25 or 30,000 watts, that interfering signals can actually cause an overload and noise on your transceiver. And the answer is to install a band reject filter on the receive side or on the antenna to your radio. An example is one right here, and it's just a filter that filters out frequencies that are above and below the frequencies that you're actually using in your transceiver. Question 8. What should you do if something in a neighbor's home station is causing harmful interference to your station? And the answers are: work with your neighbor to identify the offending device, politely inform your neighbor that the FCC rules prohibit use of devices that cause interference, and make sure that your station has no problems with cabling or grounding. And all three of those answers are correct. You want to really make sure that there's no problems at your station, that your cables are in good shape, your connectors are in good shape, and you are following good grounding practices. B9, what should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmissions? And the answer is to make sure that all of your coax cables and your neighbor's coax cables are correctly installed. There are no shorts, and they are not receiving spurious signals. Question 10. What might be a problem if you receive a report that your audio signal through an FM repeater is distorted or not intelligible? Well, there could be a lot of reasons, and all three of these answers are actually correct. Your transmitter might be slightly off frequency. In these days, that's pretty unusual, because the oscillators in modern transceivers are all controlled digitally. More common is that your transmitter can run a little off frequency if the batteries are getting very, very low. A more common reason is that you're simply in a bad location, and the transmission is being received at repeater with a very low power. But all of those answers are correct, as it could possibly be reasons why your signal is being distorted. Question B11. What is a symptom of RF feedback in a transmitter or a receiver? The most common reason, or the most common symptom, is that your signal simply doesn't sound right. It's garbled, or it's distorted, or it's not intelligible. So answer C in this case would be the correct answer for that question. Again, there are only 11 questions in this section. Section 7C, antenna and transmission measurements and troubleshooting. SWR, effects of SWR, and that kind of thing. So, question C1.
Yeah.
Got a question there? Okay, just background chatter. Question 1. What is the primary purpose of a dummy load? Examples of a dummy load are in the picture here. And the answer is to prevent transmitting signals over the air when making tests. A dummy load is simply a device you put in place of the antenna, so the signal that is being generated by your transmitter actually doesn't go anywhere. Question C2. Which of the following is used to determine if an antenna is resonant at a desired operating frequency? And the answer is an antenna analyzer. Examples are these two pictures here. This one is called a Nano VNA. They're pretty inexpensive, around less than $100. And here is another antenna analyzer. This is from a company called Rig Expert, and they tend to be a little pricey. They run in the $300 to $400 range, but they give you information about how your antenna is working, what frequencies it is resonant on, where it's got problems, and they're very, very useful. Oftentimes, a ham club will have these kinds of devices. Pardon?
So what was legal or illegal about it?
Oh, because I was making a joke because you quite literally like angled like that and then you hit it like their back like that. And I just thought it was funny. So I just worded it like that.
Okay. Question C03. What does a dummy load consist of? Most commonly, dummy load consists of a bunch of not inductive resistors mounted on a heatsink, and most commonly they are resistors in a group that present a 50 ohm load to your transmitter, because that is the impedance that your transmitter works best at. And why they are not non-inductive loads is that if they are inductive resistors, wire wound resistors, they will actually change their resistance based on frequency. So you want to use non-inductive resistors. And here's an example down here in the picture where you have a bunch of resistors connected with an RF connector here on the front. C04. What reading on an SWR meter, a standing wave ratio meter, indicates a perfect impedance match between the antenna and the feed line? The answer, since they're talking about ratios here, 1:1 is a ratio. A one to one is really hard to get. 1.2 to 1, 2.5 to 1 are good. 3 to 1 and higher is considered really bad. You can actually damage your transmitter. C5. Why do most solid state transmitters reduce the output power as the SWR increases beyond a certain level? Well, just as I mentioned, a high SWR, let's say 3 to 1 or worse, will actually protect the output amplifier transistors. Like I mentioned, your transmitter can be damaged by transmitting into a load with a high SWR, because that reflected power is actually received in the transmitter as heat, and you can actually burn out the output amplifier transistors. Very bad and possibly a very expensive fix. So you want to make sure that your antenna and feed line are actually operating at a reasonable SWR 1.2, 1.3, 1.4 in there. What does an SWR reading of 4 to 1 now indicate? And what it indicates is a very bad impedance mismatch. Like mentioned in the previous question, it can cause serious damage to your transmitter if you operate with that kind of a mismatch for a length of time. C7, what happens to the power lost in a feed line? It's not really lost, it's just not transmitted and bounces back to your transmitter and is converted into heat. And that's very, very bad for your transmitter. C8. What instrument can be used to determine SWR, standing wave ratio? And the answer is a directional watt meter. And here are a couple of examples. And most times they are not referred to as directional watt meters. They're just referred to as SWR meters. But the formal name is a directional watt meter, and that's the one in the answer. And if you've got a base station, I would highly recommend that you get one. Prices are not that bad. They start in the $60 to $70 range and go up, oftentimes way up. C9, which of the following causes failure of coax cables? Of the possible answers here, the correct answer is moisture. Moisture is the bane of coax cables. It gets inside the braid of the coax cable, causes corrosion, which causes increases in SWR or possibly failure of the cable itself. And but moisture is the correct answer, and you want to do all things possible to prevent moisture from getting to your cable. Question C10. Why should the outer jacket of a coax cable be resistant to ultraviolet light? ultraviolet light can cause damage to the cable jacket and allow water to actually get in there, which goes back to the previous questions, which says that will cause very nasty damage to the cable and actually cause the cable to fail. C11, what is a disadvantage of the air core coax cable when compared to foam or solid dielectric types? The major disadvantage is that it requires special techniques to actually prevent moisture from getting inside the cable. Here are some pictures of rigid cable. You'll notice that it's actually hollow here inside, and moisture can actually get in there very, very easily through the connectors if they're not attached properly, which can actually destroy the functionality of that kind of cable. Another disadvantage that's not mentioned here is it tends to be really expensive cable. And again, in the section, there are just 11 questions. So, getting down towards the end here, section D7 is a test equipment and soldering. So, what instrument would you use to measure electric potential? Remember that a potential is actually voltage. So the obvious answer would be a voltmeter. D2, how is the voltmeter connected to a component to measure applied voltage? Well, answer C and D really don't make any real sense when you're measuring voltage. A and B are possibilities, but the correct answer is you want to measure voltage in parallel to a component that you're testing. In the example here in the picture, you see that you have a voltmeter connected in parallel to this resistor, which you want to measure the voltage across. In fact, a more common way of phrasing the answer is that you measure the voltage across a component, which means that you're measuring in parallel to the component. D3, when configured to measure current, how is a multimeter connected to the component? Again, you've got answer C and D here, which really don't make any sense, but A and B do. And the correct answer is you want to measure in series. So, for example, you want to measure the current in this circuit. So you put your meter in series with the components that you're testing.
Father, could you move his glasses?
Pardon? Okay.
Okay.
Question D04. What instrument is used to measure electric current? Well, An ohm meter measures resistance. An electrometer measures voltage. A voltmeter measures voltage. So the right answer is an ammeter, also called an amp meter. This also that's also correct. But an ammeter measures current. Amps, amp meter. D7 they have removed. I'm not even sure what that question was originally. Question D6. Which of the following can image a multimeter? The most common way to fry a multimeter is to try and measure voltage when the meter is set to measure resistance. That will very definitely cause a short circuit inside the meter and actually probably damage it totally. And which of the following kinds of measurements are made using a multimeter? And examples are over here. These are very, very inexpensive, $10 or $12. This one can be a couple $100, but the kinds of measurements that are made are voltage and resistance.
How did the littles get to school today?
Pardon? You might want to mute your mic.
Oh, well. Had a slight problem and then I had to take 7th as your mom made her miss the bus.
Yeah, you might want to mute your mic. Okay. Anyway, but voltage and resistance are the answers to question D7. D8. Which of which of the following types of solder should not be used for radio and electronic applications? In plumbing, acid core solder is used, and if you use that when you're soldering wires in a circuit, the acid in the solder will cause corrosion and will cause your circuits to cause your solder circuit joints to become very, very corroded. So the answer is that acid core solder should not be used when you're soldering in circuits. 9. What is the characteristic appearance of a cold tin lead solder joint? A cold joint is a poor solder joint. That's just a term used. And the most common appearance of a bad or cold tin lead solder joint is a very dull and bumpy appearance. These are examples of cold solder joints. A good solder joint is smooth and shiny. D10. What reading indicates that an ohm meter is connected across a large discharged capacitor? And the answer is that resistance increases with time. An ohm meter consists of a little battery that is connected across the capacitor, and if the capacitor is discharged, the small current produced by that battery actually starts to charge the capacitor, and on the meter that is indicated by the resistance value that increases with time as the capacitor charges up. The resistance seems to increase. So the answer is answer A, that it increases resistance with time. And 11, which of the following precautions should be taken when measuring an in-circuit resistance with an ohm meter? And since the meter actually measures a current in a circuit from a battery or power supply that's inside the meter, you want to make sure that a circuit you're testing is not powered on, because you will very definitely damage the meter. And that brings us to the end of the session. Questions? Areas you need clarification on? Okay, hearing none, I guess, Steve, it's back to you.
That means I gotta wake up. Hey, Jasmine, how are you doing since you haven't been able to attend some of the sessions? Are you doing well on studying?
I put her to sleep.
I'm going to go ahead and stop the recording. We can continue conversations, obviously.